In this video, we are going to learn about two gates, AOI and OAI. What does this mean, AOI and OAI? AOI means AND, OR, invert. OAI means OR and invert respectively. Okay, what is the use of these gates? AND-OR, AND-OR and OR-AND gates can be used to implement sum of products or sum of products and product of sums respectively. The symbols of this AOI and OAI gates are as follows. So here AND. So we are going to draw an AND like this. A, B, C, D will be our inputs. So the output of these ANDs is fed to an OR because OR invert means OR complement, which means NOR. So that is why it is represented like this. So here this is AND OR invert gate, which represents the sum of two products, which is A, B and C, D. Now let us see OR and invert. It is product of sums. So it will start with OR as mentioned in the name. So let us represent two OR gates like this, and the output of these two OR gates is fed to AND invert, which means it will be not AND, which is NAND. So here the inputs let us consider as A, B, C, D. So the output will be A plus B into C plus D whole bar. It is sum, it is product of sums, two sums, product of two sums. So this is our OAI. And this OAI or AOI can be represented in three different models. What are these three different models? It is two wide, two input model. It means it will have two inputs like the one which we represented, two inputs and two stages, two wide in the sense here we have 1 and 2. 1 and 2. Correct? So it is a 2 input, 2 wide. 2 wide, 2 input 1. And we also have 2 wide, 4 input. That means it will be of 2 wide only, but the inputs will be 4. And there is also one more method, 4 wide, 2 input. And there is also 4 wide, 4 input. And this goes on. So the stages and the representation will be depending on number of inputs and how many gates are used in the first level. So this is how these can be differentiated. Now let us see an example for 2 wide 4 input. Okay, 2 wide means obviously we have 2 steps. So let us draw 2, but it is 4 input. So we will have 4 inputs. The output of this is fed to an OR, Hence comes the final output. A, B, C, D, E, F, G, H. So now the output will be A, B, C, D plus E, F, G, H whole bar. It is sum of products. So this is how it can be represented. Now let us see an example for 4 wide 2 input. 4 wide 2 input AND-OR inverter. Okay. So since it is 4 wide, it has 4 ANDs with 2 inputs. Now all these are fed to a NOR. If the inputs are A, B, C, D, E, F, G, H, then the output will be AB plus CD plus EF plus GH whole bar. So this is how these can be represented. Okay. Now let us learn what are the different gates other than this AOI and OAI. We also have some gates called special output gates. So now let us learn them. So what are the special output gates? The special output gates are used when you need different kinds of output from the same logic. For example, you need both inverted and non-inverted outputs of a particular logic. So for that, how can we get this? So these special output gates will do that. Okay, they introduce some gates called complementary gates, which will provide us two different outputs with inverting and non-inverting modes. So let us see how those can be represented. These can be represented like this. This is a buffer with inverting and non-inverting outputs. We can also represent an AND gate with inverting and non-inverting. Similarly with OR and XOR also. All the basic gates can be represented using this. So these gates are called as complementary gates. So this particular thing can be used as buffer and inverter because it has both inverted and non-inverted sides. This is inverted, this is non-inverted. Correct? So that is how it can be used. This particular one can be used as AND and NAND. This can be used as OR and NOR. This can be considered as XOR as well as XNOR. So these are used mainly where the area is of prime factor. So if you want, and also in a places where you cannot add an inverter extra because of the propagation delay, the time delay, that the input goes to the inverter, it gives the output and it goes to the main device. So in such scenarios only these complementary gates are used. So in this video finally we have learnt about what a AOI and OAI are and how many types are there and the examples for those and where they can be used. And also we have learned the special output gates, which are complementary gates in which every basic gate can be used as its own and its own complement.